In the quiet of the night, as I settle into a calm and unhurried breath, I find myself drifting toward the gentle idea of the Milky Way, not as a distant scientific object, but as a slow-moving companion that has been with us since long before we ever learned to look up. I let my mind float to that soft band of pale light stretching across the sky, and I imagine its glow resting lightly on the darkness, almost as if it were a trail of flour scattered across a black countertop. I begin thinking of the way ancient observers tried to understand that faint river of brightness long before telescopes, long before physics, long before we knew anything at all about stars or space. Some cultures imagined it as the path of lost souls, some as a road built by gods, and some as the spilled milk of a divine being, which eventually helped inspire the name Milky Way. As I breathe slowly, I feel the calm weight of knowing that this galaxy is our home in the grandest sense. A vast, slowly spinning island of stars and matter, holding us gently in one of its arms as it carries us around its center in a journey far too long for any single human lifetime to witness. When I picture it this way, not as a ball of physics equations, but as a peaceful place we inhabit, it becomes easier to drift deeper into reflection, letting each detail of its structure unfold softly, like ripples spreading across still water. I let my thoughts wander through the shape of the Milky Way, and I picture it as a great disk, wide and quietly turning, about 100,000 light-years across. Even though these numbers are enormous, almost impossible to fully grasp, I allow them to settle gently in my mind, without pressure to calculate or compare. I imagine myself floating far above the galaxy, looking down at its spiral arms like open petals. These arms contain clusters of stars, clouds of dust, and long stretches of glowing gas, all arranged in patterns shaped by gravity and time. Our solar system is tucked inside one of these arms, the Orion arm, which is not too large, not too small, gently curving along the flow of the galaxy's rotation. Because we live within the disk itself, we never see the full spiral shape from below or above. Instead, we see that soft ribbon of light spread across the sky, formed by the combined glow of millions of distant stars. The calmness of this arrangement comforts me, reminding me that even in the vastness, there is structure, and within that structure, there is a quiet place where we live. As I continue drifting through this peaceful thought, I think of the center of the Milky Way, a place so far away that its light takes around 26,000 years to reach us. At that center lies a supermassive black hole called Sagittarius A*, a point of deep gravity surrounded by whirling gas and dense star clusters. Even though the idea of a black hole can sound intimidating when spoken with sharp tone or dramatic detail, I choose to think of it here simply as the calm anchor of our galaxy. Its presence holds the Milky Way together, shaping its movements, guiding the orbits of stars the way a quiet heart guides the flow of blood. Around that central region, stars crowd together much more tightly than where we live. They shine brightly, gathering around the core like glowing lanterns placed close together on a table. Even though the center is busy and energetic compared to the peaceful outskirts where our sun rests, I imagine it all in slow motion, as if everything were moving through honey-thick space, drifting without hurry, forming patterns that took millions of years to settle into place. The Milky Way is made not only of stars, but also of vast clouds of dust and gas, drifting in shapes that look almost like watercolor strokes across the black canvas of interstellar space. These clouds are the birthplaces of new stars, and even though the process is incredibly long, I picture it gently, as if the gas were quietly gathering itself, preparing slowly for a moment when gravity will nudge it inward. Over countless years, the gas thickens, cools, and collapses, and somewhere within it, the first glow of a newborn star begins. The galaxy has been doing this for billions of years, forming stars patiently, allowing clusters to form, allowing old stars to fade away, repeating the cycle again and again. When I imagine this cycle without the rush of time, it feels like watching a long, slow tide drifting in and out. Never hurried, never forced. It's humbling to think that our own sun was born in such a cloud about 4.5 billion years ago, and that one day, far in the future, it too will gently leave its place in this cycle, just as billions of other stars have done. Yet somehow, even within these incredible spans of time, the galaxy holds its shape, continuing to turn with quiet steadiness. As I drift deeper into this reflection, I think about how many stars the Milky Way contains. Astronomers estimate that it holds at least 100 billion stars, perhaps many more, scattered throughout its disk and bulge. The number is so large that trying to count it feels impossible, like trying to count grains of sand across an entire beach. But instead of feeling overwhelmed, I let this idea ease into my thoughts like a soft blanket of small lights, each star a gentle spark, each one shining its own quiet light into the dark. Somewhere among these countless stars, there are billions of planets, many of them orbiting peacefully, some warm, some cold, some rocky, some gaseous. We have discovered only a tiny fraction of these worlds. And even though the unknown can sometimes feel intimidating, I allow it here to feel expansive instead, like a meadow stretching far beyond the horizon, full of possibilities. Among all those planets, our Earth is simply one, a small blue sphere nestled safely in the warmth of its star's light, quietly moving along its orbit as the galaxy carries it unhurried. Around the center, another calm thought drifts in. The Milky Way is surrounded by a kind of invisible glue known as dark matter. Even though dark matter cannot be seen directly, scientists can infer its presence from the way stars orbit the galaxy's center. Without this unseen mass, the galaxy would not be able to hold together. The stars would drift away. Instead, the Milky Way's rotation remains steady and graceful, supported by this mysterious substance. I imagine dark matter not as a strange or frightening concept, but as a soft, supportive halo, enveloping the galaxy like a gentle cushion, holding everything in place without ever needing to be touched or seen. It feels soothing to think of something unseen providing quiet stability, much like how the air supports our breath, without us ever needing to notice it, floating further into this gentle nightly reflection. I remember that the Milky Way is not alone. It belongs to a small cluster of galaxies known as the Local Group, which includes the Andromeda Galaxy, the Triangulum Galaxy, and dozens of smaller dwarf galaxies. Some of these smaller galaxies are like companions quietly orbiting the Milky Way, including the large and small Magellanic Clouds visible from southern skies. Over billions of years, the Milky Way and Andromeda are slowly moving closer together, drawn by their mutual gravity. One day, far in the future, they will eventually merge in a peaceful, long, drifting dance that will reshape both galaxies into a new one. Even though this event lies billions of years beyond our lifetimes, I imagine it gently, like two clouds slowly drifting together in the sky, blending without rush or noise. All of these details, its structure, its stars, its invisible halo, its distant companions come together in my mind like soft pieces of a puzzle falling quietly into place. In this calm mental space, the Milky Way does not feel like an overwhelming concept measured by vast numbers. It feels instead like a peaceful home, existing on a different scale of time and size, but still familiar in its steady rhythm. Thinking of it this way brings a sense of stability, as if the galaxy itself breathes slowly, carrying us gently through the universe without hurry, without pressure, without expectation. As I ease into the calmness of the night, I imagine myself drifting deeper into the gentle glow that fills the galaxy. A glow made not of any single bright source, but of countless stars whose light has softened as it travels across unimaginable distances. I let myself settle into this thought the way one might settle into a comfortable pillow, slowly and without any need for hurry, allowing every detail to stretch out at its own unforced pace. When I think of starlight in this quiet way, I can almost feel it brushing gently across the darkness, not in sharp beams or sudden flashes, but in a long, peaceful wash of brightness that has been traveling for thousands, sometimes millions, of years. The light we see from many stars near the edges of the Milky Way began its journey long before any human existed, long before even the earliest creatures took their first steps on land. And yet that light continues on, moving silently and steadily, never rushing, never fading too quickly, simply carrying the signature of its star across empty space. As it finally reaches us and lays itself softly across our eyes, it feels almost like a whisper from another time, a reminder of how deeply connected everything is, even across impossible distances. As I breathe slowly and allow the softness of this thought to deepen, I imagine wandering quietly among the stars. I picture myself floating in a gentle darkness where each tiny point of light shines with its own peaceful glow. Some stars burn with a warm golden hue, like the quiet flicker of a candle in a dark room. Others shine with a soft blue-white light, not harsh or cold, but simply pure and calm, shaped by their immense heat and energy. Even the red stars, small and faint, send out light that feels comforting in its own way, like embers resting at the bottom of a fire that has long since burned low. These different colors of starlight come from the temperatures and ages of the stars, and even though the physics behind them can be complex, I choose to think of them here simply as varieties of gentle glows, each one telling its own slow story of time and change. It soothes me to imagine these colors quietly blending across the galaxy, creating a tapestry of light that never demands attention but always invites reflection. I also let my thoughts wander to the idea that starlight is more than just illumination. It is also a guide. For centuries, people used the stars to find their way across oceans and deserts, trusting the slow, steady patterns they traced in the sky. The Milky Way itself served as a natural compass, stretching from horizon to horizon like a soft, glowing path. I imagine travelers from long ago looking up on quiet nights, much like I am now, and finding comfort in the consistency of the stars. They saw the same patterns night after night, year after year, guiding them with a subtle assurance that the universe was stable and reliable. When I picture this ancient connection to starlight, it brings an even deeper sense of calm, as though the same light that guided those travelers is gently guiding my thoughts now, helping them flow without tension or haste. Slowly, I drift to the idea of how starlight forms. Deep within every star, nuclear fusion quietly transforms hydrogen into helium, releasing energy that makes its way from the core through layers of gas before escaping into space. even though this process involves incredible pressures and temperatures. I imagine it as something slow and steady, like a long, continuous exhale. This energy then travels across space, spreading thinly as it moves outward, until it becomes the soft glow we see from Earth. The energy itself has no sound, no harshness, no rush. It is simply the natural expression of a star's existence, a gentle output that continues day and night, without pause. It comforts me to think of stars shining not because they must, but because that is simply what they do. Their light is constant and unhurried, shaping the calm ambience of the night sky. I allow my mind to wander further through the galaxy's vast expanse, imagining regions where stars are born. These stellar nurseries are filled with clouds of dust and gas, illuminated softly by the light of newly formed stars hidden deep within them. The starlight filtering through these clouds appears diffused, like sunlight passing through fog in early morning. It spreads gently, creating soft colors blue, where hot young stars shine through thinner regions of gas, red where the light must pass through thicker clouds. These birthplaces of stars feel quiet to me, as if the gas and dust themselves were resting in a tranquil stillness, gathering slowly as gravity shapes them over millions of years. Even though the formation of a star is a powerful and transformative process, I imagine it here with a softness, as if the universe were carefully cradling the new light that will one day join the peaceful glow of the galaxy. As I continue floating through this thought, I picture older stars nearing the end of their long lives. Some swell into red giants, softly brightening as their outer layers drift outward like thin curtains of gas. Others shed material that forms glowing shells of dust around them, lit gently by the fading star within. I imagine these shells expanding quietly, like ripples moving outward across still water. The starlight that shines through them appears delicate, almost fragile, yet it carries within it the history of the star's life. When I think of these aging stars, it brings a sense of tranquility, as though they, too, are settling into a long rest, allowing their final light to drift gently into the galaxy. As my thoughts deepen, I begin thinking about how starlight interacts with the galaxy itself. Dust scattered throughout the Milky Way dims and reddens the light from distant stars, not in a harsh or disruptive way, but in a soft filtering motion, like thin curtains being drawn across a window. This effect is called interstellar extinction, and even though the name might sound technical, the idea feels simple and soothing when I picture it. The dust does not block the light completely. It simply softens it, giving the galaxy a warm, mellow glow. Sometimes this dust gathers into long dark streaks across the bright band of the Milky Way, creating gentle shadows that weave through the light. These shadows remind me that even within brightness, there is room for softness and quiet depth. The slow rotation of the galaxy also influences the glow of starlight. As the Milky Way turns, stars move in graceful orbits around the center, carrying their light with them. This motion is so slow from our perspective that we cannot detect it in a single lifetime. Yet it continues without rushing, without pause. The galaxy takes hundreds of millions of years to complete one full turn, and I imagine this rotation as a gentle, drifting swirl, like a calm current spreading through a vast ocean. The stars, carrying their quiet glow, move with this current, shaping patterns of brightness that flow gradually across the galaxy. It brings a deep sense of peace to think that even though everything is in motion, that motion is steady, patient, and balanced. As I settle deeper into this quiet imagining, I think of the moments when starlight reaches Earth, passing through the layers of our atmosphere. The air gently bends and scatters the light, causing stars to twinkle softly. Even though the physics behind this effect involves different temperatures and densities in the air, the result feels like a simple, gentle shimmer. The twinkling of stars has soothed observers for centuries, offering a reminder that even the light from distant suns can appear playful, delicate, and comforting. When I picture those tiny, sparkling points across the sky, each one carrying the ancient glow of a star, it wraps me in a feeling of deep calm, as though the night itself is breathing slowly with me. As the thought of starlight continues to drift through my mind, I also reflect on how rare it is, in the vastness of the universe, to see such a clear glow. Many galaxies are obscured by dust, or too far away to reveal themselves with any clarity. But here, within the Milky Way, we are surrounded by a gentle haze of starlight that has accumulated over billions of years. It stretches across the sky in a long arc, forming the faint band that gave the galaxy its name. On clear nights, far from city lights, this band becomes visible to the naked eye, appearing like a soft brushstroke of brightness across the darkness. When I imagine lying beneath that glow, whether on a quiet field or a silent mountainside, I feel a deep sense of belonging, not just to Earth, but to the entire galaxy that carries us through space. All of these thoughts, the birth of stars, the aging of stars, their colors, their motions, their gentle filtering through dust and atmosphere blend together into one slow, peaceful reflection on the nature of starlight. It is a glow that has been shining long before we existed, and it will continue long after we are gone. It does not rush, does not demand, does not fade quickly. It simply travels, quietly and steadily, across the emptiness, bringing with it a sense of serenity that reaches across time itself. As I settle more deeply into this calm state of mind, I find comfort in knowing that even when the night feels dark or distant, that soft glow is always there, carrying the quiet presence of countless stars. In the slow quiet of the night, as I let my breathing become soft and steady, I begin to drift into the calm idea of cosmic dust, the tiny, delicate grains scattered throughout the Milky Way that seem almost insignificant when viewed individually, yet together create some of the most serene and quietly enchanting features of our galaxy. I imagine each grain of dust not as something harsh or gritty, but as a small, floating particle that moves softly through space, drifting without urgency, shaped only by the gentle pull of gravity and the faint pressure of starlight. These grains are incredibly small, many no larger than smoke particles, yet over millions of years they gather into long, drifting lanes and soft clouds that stretch through the galaxy like faint watercolor brushstrokes. When I picture these clouds, I feel no sense of chaos or disorder. Instead, I sense a slow, peaceful movement, as though the dust is resting on invisible currents that carry it across the galaxy, shaping quiet patterns that will last for ages. Even though cosmic dust is made of microscopic pieces of carbon, silicon, ice, and metals, I like to imagine it here not as a scientific concept, but as a soft, mist-like presence, a gentle companion to the stars, adding depth and shadow to the glow of the Milky Way. I let myself ease further into thoughts of how this dust forms, and I imagine the long, slow processes that create it. Some dust is born from the outer layers of aging stars, drifted outward gently as those stars exhale their material into space. Other dust is created in the aftermath of supernova, the cosmic explosions that scatter elements across the galaxy. Even though the word explosion can bring images of sudden, violent action, I allow the idea here to soften, thinking instead of the long-term result, dust drifting outward over thousands of years, settling slowly into the galaxy like fine ash after a distant fire. The dust then becomes part of the interstellar medium, the vast, calm ocean of gas and matter that fills the spaces between stars. I picture these grains traveling quietly, sometimes wandering alone through open space, sometimes gathering into denser clouds where they lie gently in the cold darkness, waiting for their next role in the long, slow cycle of the galaxy. In this way, cosmic dust feels almost like a traveler, ever bound to one place for too long, always drifting, always shaping new paths. As I drift deeper into this peaceful thought, I imagine how cosmic dust interacts with starlight. Dust doesn't simply absorb light. It scatters it in gentle, delicate ways that soften the glow of stars and create subtle color changes. When starlight passes through dust, its shorter blue wavelengths scatter more easily, allowing the longer red wavelengths to slip through, giving distant stars a warm, quiet hue. This softening of starlight feels soothing, like light filtering through thin curtains in a dimly lit room. The dust also creates beautiful, tranquil shapes called dark nebula clouds, so dense that they block the light behind them, forming gentle shadows across the bright band of the Milky Way. These dark patches are not empty. They are full of drifting particles gathered together, quietly resting until gravity eventually shapes them into something new. When I imagine these dark nebulae stretched across the sky, it brings to mind the calmness of evening clouds passing over the setting sun, quietly shifting the light into softer tones. I continue drifting through this thought, letting my mind move slowly toward the role cosmic dust plays in the formation of stars. Within the densest dust clouds, gravity begins to nudge the particles closer together, and over millions of years, these clouds compress into regions called molecular clouds. Although the process involves enormous scales of time and space, I imagine it unfolding with complete stillness, almost like watching fog slowly thicken as night falls. Within these dense regions, pockets grow colder and denser, and eventually, the gentle pressure of gravity causes the material to collapse inward, forming a small, bright point at the center, a young star beginning to shine. Cosmic dust both shelters and shapes these early stages of star formation. It absorbs the energy emitted by the young star and glows softly in infrared light, invisible to the human eye, but radiant in its quiet warmth. Thinking of dust playing this role, I feel a calm appreciation for how something so small can contribute so meaningfully to the cycle of creation within the galaxy. As I settle more deeply into this reflection, I imagine the drifting paths dust travels through. In the spiral arms of the Milky Way, the motion of the galaxy gently gathers dust into lanes that thread through the arms, like calm streams flowing through a larger river. These dust lanes appear as soft, dark bands when viewed from inside the galaxy, weaving between clusters of bright stars. I picture these lanes as long, quiet corridors where dust moves slowly along the galaxy's rotation, following the graceful curve of the spiral arms. Even though the stars and dust are all in motion, the movement feels so balanced and so slow that it creates an impression of steadiness, almost as if the galaxy were holding its breath in a peaceful moment of stillness. This slow orbital motion takes hundreds of millions of years to complete, yet every bit of dust within the galaxy participates in it, carried along by gravity in a glide that never feels rushed. The more I think about the path of cosmic dust, the more I imagine how it shapes the soft textures we see in the night sky. When dust reflects the light of nearby stars, it creates beautiful, gentle formations called reflection nebulae. These nebulae often appear blue because the dust scatters blue light more efficiently. But the color is never sharp or intense. It's always muted and calming, like moonlight spread thin across rippling water. I imagine these nebulae floating quietly in space, illuminated just enough to show their delicate shapes. The dust within them does not glow on its own. It simply reflects the light that reaches it. In this sense, reflection nebulae remind me of how calm water reflects the sky without ever altering its own nature, simply allowing the light to rest upon it. Many of the most famous star-forming regions in the Milky Way are surrounded by these reflection nebulae, giving them a soft, peaceful blue glow that seems to drift gently through space. My thoughts settle next on the way cosmic dust helps create the beautiful reddened sunsets we see on Earth. Dust floating in the upper layers of our atmosphere interacts with sunlight in much the same way dust interacts with starlight in space. When the sun sits low on the horizon, its light travels through more of the atmosphere, causing the shorter blue wavelengths to scatter away and allowing the warmer red wavelengths to reach our eyes. Even though this phenomenon happens close to home, it connects us directly to the broader behaviors of dust throughout the Milky Way. It reminds me that the same soft scattering happening in distant nebulae also shapes the gentle glow of familiar sunsets, linking the calm beauty of Earth to the quiet processes that unfold across the galaxy. As I continue drifting through these quiet thoughts, I imagine the journey cosmic dust takes when it becomes part of a forming planetary system. In the early stages of planet formation, dust gathers around a young star in a large, slowly rotating disk. These grains bump into each other gently, sticking together over long stretches of time, forming small clumps that eventually grow into larger bodies. This slow accumulation forms planets, moons, asteroids, and comets. I pictured these tiny grains beginning their journey alone, drifting through the galaxy for perhaps millions of years before finally finding a new home within a forming star system. To me, this feels like a deeply soothing reminder of how the universe reuses everything, how nothing is truly lost, only transformed. The dust that once belonged to an ancient star might one day become part of a new world, perhaps even a world capable of supporting life. Thinking of this slow recycling brings a sense of peace, as though the universe itself practices a calm, endless cycle of renewal. The final thought that settles gently into my mind is the simple, comforting idea that cosmic dust is always moving, always drifting, always participating in the quiet motions of the galaxy. It does not rush. It does not resist. It simply follows the soft guidance of gravity, starlight, and time, forming patterns and textures that shape the Milky Way's calm beauty. In this way, cosmic dust becomes more than just the building material of stars and planets. It becomes the soft breath of the galaxy itself, drifting through space with steady patience. In the gentle quiet of the night, when I let my breathing slow and my thoughts stretch softly across the vastness of space, I begin to imagine the spiral arms of the Milky Way not as rigid structures or sharp outlines, but as immense, drifting pathways of light and dust that turn with a patience beyond anything on Earth. These arms sweep outward from the galactic center like long, delicate ribbons, moving through dark space with a smoothness that feels almost like a deep breath drawn slowly in and released without any hurry. Even though the arms appear when we picture them to be permanent, solid spirals, when I settle into the calmness of this thought. I remember that they are really patterns shaped by the quiet influence of gravity and the steady motion of countless stars. They are not fixed, not frozen. They are waves, flowing gently through the disk of the galaxy. Stars move in and out of them the same way leaves drift through a slow-moving current in a wide, peaceful river. The arms create the illusion of structure, but each star within them follows its own orbit, passing through the denser regions of starlight and gas before drifting outward again, continuing the long journey that takes hundreds of millions of years to complete a single circuit around the galactic center. As I picture this, I imagine myself floating above the galaxy, watching the arms turn with a softness so deep and steady that time itself seems to stretch into a quiet stillness. Nothing rushes, nothing snaps. Everything shifts with a slow and delicate grace that feels deeply soothing, like watching the gentle rotation of a far-off lantern illuminating a dark, silent landscape. The spiral arms become even more calming when I imagine what creates them. The Milky Way's arms form through what astronomers describe as density waves, subtle, persistent patterns that move through the galactic disk like gentle ripples. These waves compress gas and dust slightly as they pass, and in those regions of compression, new stars are born. I imagine these waves as invisible hands pressing softly on the gas of the galaxy, gathering it just enough to spark the warm light of new stars. The star-forming regions glow brightly but never harshly. They shine like distant clusters of candles scattered along a winding path. As these newborn stars ignite, they illuminate the surrounding dust clouds, turning them into luminous pockets of softly colored light pale pinks from glowing hydrogen, cool blues from reflected starlight, deep indigos, where the dust remains thick enough to cast gentle shadows. These glowing regions settle peacefully into the slow-turning arms, adding brightness to the waves as they drift through the disk. When I imagine this process, it feels like the galaxy is quietly breathing, each spiral arm expanding and contracting with the subtle rise and fall of stellar birth and movement. But even as stars light up these regions, they do not remain there forever. They drift away from the arms over time, carried by their own orbital paths into quieter parts of the galaxy where the density of gas and dust thins out. This slow drifting gives the arms their soft edges, their delicate, feathered outlines that blend gradually into the surrounding disc-like watercolor strokes fading across a page. Nothing in the arms has a sharp boundary. Everything blends, everything flows. Everything moves together in an unhurried balance shaped by gravity and time. As I drift deeper into this thought, I begin to imagine our sun's place within this slow dance. The sun resides in a smaller, calmer region called the Orion Arm, sometimes described as a spur or a minor branch compared to the larger Sagittarius and Perseus arms. I picture our position not as a busy intersection of star formation, but as a quiet neighborhood tucked gently between brighter, more active regions. Here, the stars are spaced comfortably apart, and the wide stretches of interstellar dust drift peacefully, creating a calm environment where the sun can continue its long orbit around the center of the galaxy without disturbance. Our solar system moves along this orbit at a steady pace, carried by the galaxy's overall rotation. But because the galaxy is so large, and the sun's path so long, it takes about 225 to 250 million years for the sun to complete a single revolution around the center. When I think of this span of time, it feels almost dreamlike. The last time the sun was in this position in its orbit, the dinosaurs roamed the Earth, the continents were arranged differently, and the world was filled with creatures and landscapes that no longer exist. The Sun has made only about 20 orbits around the galactic center since it formed. And as I reflect on this, I imagine the Sun drifting through the Orion Arm, gently carried by the galaxy's rotation, moving so slowly relative to the structure of the arms that its motion feels more like a serene glide than a journey. It follows the calm, quiet current of the galaxy's gravity, never in a rush, never pushing against anything, simply following the ancient path set for it by the Milky Way's elegant design when we picture the spiral arms from an even greater distance. Allowing my mind to float far above the galaxy like a quiet observer watching a slow, cosmic ballet, I begin to imagine the peaceful contrast between the brighter, denser regions of the arms and the darker, quieter spaces between them. The spaces between the arms are not empty, but they are more tranquil places where material stretches thin, where stars are scattered more widely, and where the faint glow of the galactic disk settles into a soft haze. I imagine drifting through these quieter regions, floating gently among stars, separated by vast distances, feeling no pressure, no sense of bustling movement, no slow, balanced rotation of the galaxy holding everything in place. The spiral arms curve outward from the core like graceful arms in a slow-motion dance, and each arm is shaped not by the movement of individual stars but by the collective influence of gravity, gas, and time blending into a pattern that has persisted for billions of years. And as the arms turn, they change. Their shape evolves gradually, almost imperceptibly, over unimaginable stretches of time. New branches of arms can sprout from the main spirals. Older sections can fade as material spreads outward. But none of these changes happen quickly. They unfold with the patience of a universe unbound by human scales of time. To imagine this is to feel a deep, quiet calm settle into the mind as though the galaxy itself is teaching the meaning of stillness. What soothes me even more is the thought that the entire spiral structure is held together, not only by the visible stars and dust, but also by the gentle, unseen presence of dark matter. This invisible halo surrounds the galaxy and supports the rotation of the arms, ensuring that stars far from the center can continue their slow orbit without drifting away. I imagine dark matter not as something mysterious or frightening, but as a soft, quiet foundation, a stabilizing layer that holds the galaxy in a steady, graceful balance. It does not push, does not pull sharply, does not disturb the slow dance of the arms. It merely cradles the galaxy, allowing the delicate spirals to maintain their form over billions of years. This invisible support makes the motion of the arms feel even softer, even more peaceful, as though the entire galaxy rests on a cushion of calm, unseen energy that allows each star, cloud, and particle to follow its natural path without disruption. As I let my mind drift through these thoughts, I begin to imagine the outer edges of the Milky Way, where the spiral arms stretch thinner and more fragile. Here, the stars are spaced far apart, and the dust clouds grow faint. The spiral pattern becomes subtle, like the last faint strokes of paint near the edge of a canvas. These distant fringes feel profoundly quiet, almost timeless, and yet they are still part of the same gentle rotation that governs the entire galaxy. Even at these extremes, the arms turn without pause, but so slowly, so softly, that their motion feels almost like a whisper carried on the breeze. In these outer regions, stars follow wide, leisurely orbits that span tens of thousands of light years. When I imagine floating there, drifting peacefully among the faint outer stars, I sense a silence deeper than anything on Earth, a stillness shaped by the absence of urgency. Everything is calm. Everything moves, but nothing feels like motion. And when I bring all of these reflections together, the density waves, the drifting stars, the birth of new light, the sun's slow orbit, the quiet outer regions, the supporting presence of dark matter, I begin to feel the spiral arms of the Milky Way not as astronomical structures, but as symbols of gentle continuity. They show that even on the largest scales imaginable, the universe moves with a patience that feels soothing to the mind. The galaxy does not rush. It turns with the same unhurried rhythm it has kept for billions of years, carrying our tiny world along with it, holding everything in a calm, quiet embrace. When I let my thoughts drift slowly outward from the bright, spiraling disk of the Milky Way, I begin to sense a quiet region that surrounds the galaxy like a soft, invisible shell. This is the galactic halo, a vast, faint, and peaceful sphere of ancient stars, wandering clusters, and unseen matter. Unlike the busy disk full of young stars, glowing nebulae, and the gentle swirl of spiral arms, the halo feels almost weightless, like a calm breath held just beyond the edges of the galaxy's brighter light. Here, the stars drift in wide, leisurely paths, moving not in the ordered rotation of the disk, but in slow, individual orbits that stretch across enormous distances. When I imagine floating within this quiet halo, I feel as though I am drifting in a place untouched by urgency, a region where time expands and moves with a softness that feels almost infinite. The stars in the halo are among the oldest in the galaxy. They formed when the universe itself was young, their light shaped in an age before the Milky Way took on its spiral form. These ancient stars are dim and sparse, spread so far apart that each one seems to exist in its own quiet pocket of space. When I picture them, I imagine them as gentle, flickering embers floating in a vast darkness, each carrying the calm memory of a time long before the sun was born. There are no bright, crowded regions here, no dense clusters of swirling gas. Instead, everything feels open and airy, like a peaceful meadow under a night sky so clear that even the faintest stars seem to shimmer with quiet dignity. These old halo stars remind me that the galaxy has lived through countless ages, and that its earliest moments are still softly present in the stillness. Surrounding the disk, I also think about the globular clusters, those tight, ancient gatherings of stars that drift slowly through the halo like glowing islands in a silent sea. Each cluster contains hundreds of thousands of stars, packed together into a round, bound shape that has remained stable for billions of years. When I imagine approaching one of these clusters, I feel as though I am nearing a lantern drifting gently through a dark and quiet ocean. The stars within it shine warmly, held together by their shared gravity, their light blending into a soft, luminous glow. Some of these clusters orbit far above and below the galactic plane, taking enormous and slow paths that can last hundreds of millions of years. They do not hurry around the center. They simply drift in their own serene rhythm, always held by the galaxy's gentle pull. To imagine their motion is to imagine a quiet, timeless dance, steady, patient, and deeply calming. One of the most tranquil aspects of the halo is the way it extends far beyond the visible edges of the Milky Way's disk. The disk itself is only a thin layer compared to the immense halo that envelops it. As I let my mind float outward, I notice how the visible stars gradually fade, how the soft glow of the disk thins into a delicate haze, and how the halo continues outward for hundreds of thousands of light years. It stretches so far that it is difficult to sense its boundary. It feels not like a sharp edge, but like a gentle blending into the deeper darkness of intergalactic space. In this transition, everything feels smooth, quiet, and spacious. No rushing winds of gas, no bright waves of star formation, only a soft scattering of ancient stars and the calm, invisible presence of dark matter. It is a place where one could drift endlessly without feeling lost, because the halo itself seems to hold everything in a peaceful embrace. Dark matter forms the majority of the halo, shaping its size and its calm gravitational pull. Even though dark matter cannot be seen, I imagine it as a soft, unseen cushion surrounding the galaxy, holding the stars of the halo in their wide orbits. It feels like a quiet foundation, something gentle and non-intrusive that supports the motion of the entire Milky Way. Without dark matter, the outer stars and clusters would not have the calm, stable paths they do. Instead, they are cradled by its presence, drifting smoothly through the halo with no abrupt changes, no startling motions. Thinking of dark matter this way turns something mysterious into something soothing, an invisible calmness that shapes the galaxy with patient steadiness, like a quiet current guiding leaves across the surface of a still pond. As I drift deeper into the quiet halo, I imagine the difference between the motions here and the motions in the disk. Inside the disk, stars orbit in a more organized way, following the general rotation of the galaxy. But in the halo, the paths of stars and clusters tilt and curve in all directions. It is not chaotic. It is simply free. The stars move gently wherever their long histories have taken them, forming a serene cloud around the galaxy rather than a flat, rotating plane. I picture these paths like slow, drifting spirals on different planes, some angled upward, some downward, some looping softly in wide arcs. Each star carries its own calm movement, shaped by billions of years of quiet travel. Together, they give the halo a sense of vastness that feels almost like an open sky surrounding the busy lights of a distant city. The halo also carries traces of smaller galaxies that merged with the Milky Way long ago. These remnants drift like faint memory streams of stars that once belonged to other worlds, now stretched into long, delicate trails that wrap softly around the galaxy. When I imagine encountering one of these star streams, I picture it as a gentle ribbon of light floating silently through the darkness. These streams are not bright or dramatic. They are subtle, faint, and calming, blending into the halo with a gentleness that suggests time has softened their boundaries. They remind me that the Milky Way itself has grown not through violence, but through slow, natural gathering, bringing smaller galaxies into its embrace over billions of years. Even these mergers, which sound dramatic from a scientific perspective, become peaceful when viewed over cosmic timescales. Quiet processes that unfold gradually and settle into the steady stillness of the halo dot. The temperature of the halo adds another layer of quietness. Although much of the gas here is incredibly hot than anything we could imagine experiencing, the halo itself feels serene because the gas is spread out so thinly that its heat carries no sense of pressure or turbulence. It drifts quietly, barely touching any passing star or cluster. When I imagine this gas, I picture an extremely faint, warm mist spread so lightly across the halo that one could drift through it without feeling anything at all. There are no roaring winds, no dense clouds, no shouts of energy, only a gentle, near-invisible presence that fills the space between stars with a peaceful warmth. The sheer scale of the halo is one of the most soothing things to visualize. The visible disk of the Milky Way is about 100,000 light-years wide, but the halo stretches several times farther. It is a vast, spherical cushion of stillness surrounding the busy central disk. When I picture floating from the disk into the halo, it feels like stepping from a softly lit room into a wide, open field at night, a quiet, expansive space where the stars seem more distant, yet their presence feels even more peaceful. The further outward I drift in my imagination, the more I sense the calm of that openness. The halo does not end abruptly. It fades gently into the darkness that lies between galaxies. That transition feels like drifting from a quiet place into an even quieter one, where the soft pull of the Milky Way begins to fade, but never truly disappears. Even the concept of time feels different in the halo. Events unfold, not just slowly, but almost imperceptibly. A star takes billions of years to complete its orbit. A globular cluster drifts in its path for ages so long that entire planetary systems could rise and fade in the time it takes for the cluster to make a single journey around the galaxy. Inside this region, time seems to stretch out, growing softer and less demanding, as though the halo exists in its own gentle rhythm that is far removed from the more dynamic processes happening in the disk. When I let my mind rest in this rhythm, I feel the same sense of stillness settling into me, a quiet reminder that the universe is vast, calm, and unhurried, and that even the most ancient parts of the galaxy continue to drift with patient grace. And when I picture the halo from far outside the galaxy, I imagine it as a soft, faint glow surrounding the Milky Way like a gentle aura. The halo gives the galaxy a sense of wholeness, a silent sphere that completes the structure of the spiral arms and the central bulge. Without the halo, the Milky Way would feel incomplete, like a lantern without the gentle softness of the light around it. But with the halo, the galaxy feels calm and balanced, as though wrapped in a blanket of peaceful starlight and quiet gravity. In this soothing vision of the halo, I find a deep comfort. It reminds me that the universe is not just full of motion and energy, but also full of places where stillness reigns. The halo is one of those places, a quiet border around our galaxy where ancient stars drift, like peaceful lights in an endless night. And as I let my imagination drift through this tranquil realm, I feel my own thoughts slow, my breathing deepen, and a gentle calmness settle softly around me, much like the quiet halo that holds the Milky Way in its serene embrace. When I let myself drift gently into the stillness of the night and think about the oldest stars in the Milky Way, I imagine their light as something soft, steady, and profoundly patient, trees that have traveled across space for thousands of years just to reach us, carrying with them the quiet memory of a time when the galaxy itself was young. These ancient stars are scattered across many regions of the Milky Way, some resting quietly in the halo, others gathered closely within globular clusters, and still others drifting through the thickened bulge near the galactic center. They shine with a gentle faintness that feels soothing, like distant lanterns glowing softly across a wide, open field. Their colors tend to be warm, leaning toward deep reds and subtle yellows, reminding me that they have burned steadily for billions of years, using their fuel slowly and patiently, without the intense brightness or youthful energy of newer, hotter stars. When I imagine floating among them, I picture a peaceful expanse where each star radiates a calm and enduring light, giving the entire galaxy a sense of quiet continuity and assurance that even in the vastness of space, there are things that persist with gentle steadiness. These ancient stars formed long before the sun existed, in an era when the galaxy was still growing from smaller clouds and merging fragments. Their composition reflects that early time. They contain far fewer heavy elements than younger stars do, because the universe had not yet produced many of those elements. I imagine them as clean, simple flames, burning with the pure hydrogen and helium that filled the cosmos shortly after the Big Bang. Their lack of complex elements gives their light a kind of clarity, a smoothness that feels almost serene. And because they formed so early, these stars are like quiet witnesses to the entire history of the Milky Way. They have watched the spiral arms form and shift. They have drifted gently through the slow expansion of the halo. They have endured the rise and fall of star-forming regions. When I think about their long lifespans, stretching across billions of years, I feel a deep calmness take hold, because these stars remind me that time itself can be slow and peaceful, and that the universe often moves with a patience we can only begin to imagine. Many of the oldest stars gather together in globular clusters, those dense spherical groups that orbit the galaxy like soft, glowing pearls suspended in the halo. When I imagine approaching one of these clusters, I picture a warm, tightly packed ball of light slowly drifting through the darkness. Thousands upon thousands of ancient stars fill the cluster, shining together like a calming lantern. The gravitational pull within these clusters keeps the stars bound closely, giving them a sense of unity, as though they have been keeping one another company for billions of years. Their motion inside the cluster is gentle and balanced, each star orbiting quietly around the center, weaving through the cluster in smooth, looping paths. I imagine floating at the edge of such a cluster, watching the combined glow of all those old stars blending into a single, soft, golden radiance. There is no noise, no turbulence, nothing rushed or frantically. The calm, shared light of ancient suns breathing steadily in the darkness. These clusters have survived for so long, because their stars burn slowly and peacefully. Most of the stars in globular clusters are low-mass stars, the kind that shine for tens of billions of years without swelling into giants or collapsing into supernova. Their quiet endurance gives each cluster a feeling of stability, as though it has been resting in the halo since the earliest days of the galaxy. Some of the stars in these clusters are nearly as old as the universe itself, more than 12 billion years old. When I reflect on those numbers, I picture the clusters as ancient guardians, carrying with them the memory of the Milky Way's long and gentle evolution. These ancient lights glow with a calming constancy that mirrors the softness of their surroundings, reminding me that deep in the galaxy, there exist places where time stretches out like a calm ocean, undisturbed by anything but the slow passage of stars. Closer to the center of the Milky Way, the oldest stars are found within the galactic bulge, thick, rounded region of stars packed densely around the core. The bulge is not as quiet as the halo, but it still carries a sense of age and stability. The stars here are older on average, and many of them have settled into long, slow orbits that loop through the central region like strands of quiet, glowing thread. The environment is more crowded, yet the age of these stars gives their collective light a deep, warm quality, rich golds, soft ambers, and faint reds blending together into the gentle glow we see when we look toward the constellation Sagittarius. I imagine drifting through the bulge, moving slowly between stars that have shone for billions of years. Despite the higher density of stars, I still sense a calmness, because the stars here are not racing or clashing. They are simply flowing through the long-established structure of the galaxy's inner region, following paths that have existed since ancient times. Some of the oldest stars in the bulge follow elongated orbits that carry them close to the galactic center before pulling them outward again. These orbits take millions of years to complete, and so each star's journey feels stretched and unhurried, unfolding in a rhythm that matches the deep, slow heartbeat of the galaxy itself. The center of the Milky Way contains a supermassive black hole, but even there, the ancient stars move with a kind of elegance. Their orbits do not feel violent. They feel like part of a gentle gravitational choreography that has been unfolding for ages. The black hole, despite its power, sits quietly, disturbing nothing unless a star ventures very close. Most stars in the bulge never approach it. Instead, they maintain their slow, looping paths, adding to the calm glow of the inner region beyond the clusters and the bulge. Many ancient stars drift freely through the halo, unbound to any group. These solitary elders move along long, gentle orbits that extend far above and below the galactic disk. I imagine them as lone lights drifting through a wide, peaceful darkness, taking billions of years to trace a single path around the center. Their isolation does not feel lonely. Instead, it feels restorative, like being in a quiet place where one can breathe and move freely without disturbance. These stars have survived mergers, tidal interactions, and the slow reshaping of the galaxy's structure. Their endurance gives them a kind of quiet dignity, as though they have weathered every change with gentle resilience. One of the soothing things about ancient stars is that they shine steadily without flickering. Their long lifespans mean they convert their fuel slowly, releasing their light in a calm, consistent glow. Young stars may flare, pulse, or burn with intense heat, but the ancient ones radiate with a smoothness that feels almost meditative. Their steadiness helps astronomers measure the age and history of different regions in the galaxy, but for me, their steadiness feels like a gentle reminder of stability and assurance that across unfathomable stretches of time, these stars have continued to shine without haste or interruption. Another comforting thought is how these stars help shape the identity of the Milky Way. Their light contributes to the faint, warm glow that surrounds the galaxy. Their orbits create the soft, scattered structure of the halo. Their clusters move in elegant patterns through the outer regions. Their presence near the galactic center adds depth and richness to the glow of the bulge. And through all of this, the ancient stars remain quiet, enduring, and calm, giving the galaxy its sense of age and serenity. Without them, the Milky Way would feel younger, more rushed, more turbulent. But with them, it feels balanced, peaceful, and timeless. These old stars also remind me that the universe grows in layers. The oldest stars formed first, then the younger ones, and then new generations continued building the galaxy's structure. The ancient stars sit at the foundation of everything that came after, like deep, steady roots holding up the vast canopy of the modern Milky Way. When I imagine their slow, enduring glow, I feel as though I am looking at the quiet base layer of the galaxy, a layer that supports the brighter activity of the disk and the spiral. Arms without ever demanding attention for itself, floating among these ancient stars in my imagination, I feel a deep sense of calm. Their steady light, their long histories, and their gentle motions through the galaxy weave together into a soothing picture, a reminder that not everything in the universe moves quickly or burns brightly. Some things simply shine with quiet persistence. Some things endure with a soft patience that stretches across ages. And as I rest in that image, I feel my own breath slow and my mind settle. as though the calm light of the ancient stars has reached me across the darkness, offering the same gentle peace that they have shared with the Milky Way for billions of silent years. When I let my thoughts drift back into the quiet, slow-turning regions of the Milky Way, I often imagine the places where new stars are born, the soft, glowing nurseries scattered gently throughout the galaxy. These star-forming regions are not loud or fiery in the way they are sometimes described. Instead, when I picture them for bedtime calmness, I imagine them as wide, peaceful clouds of gas and dust, drifting slowly through the spiral arms, carrying within them the warm potential for new starlight. These nurseries, often called nebulae or molecular clouds, are enormous, but their glow is gentle, like the faint illumination of dawn behind a curtain of soft mist. They are made of hydrogen, dust grains, and molecules that gather quietly over millions of years, thickening slowly into the calm cocoons where stars gradually take shape. When I imagine floating through one of these nebulae, everything feels hushed and serene, as though the galaxy itself is holding its breath, waiting patiently for new stars to open their eyes to the quiet darkness around them. Most star nurseries are found within the spiral arms, because those arms compress the gas as they drift through the disk like slow-moving waves. The compression is not sudden or forceful. It is gentle, like a cloud being pushed softly by a passing breeze. Over long ages, the gas becomes dense enough that gravity begins to draw it inward, forming pockets of material that slowly contract. I imagine these pockets as warm, dimly glowing spheres hidden deep within the cloud, gradually becoming brighter as the forming star inside grows hotter. The process is incredibly slow, unfolding across millions of years, and everything about it feels peaceful. There is no rushing, none sudden burst, only a gradual gathering of warmth, a slow brightening, like a candle being kindled in the quiet of a dark room. Some of these nurseries are enormous and famous shapes and colors we often see in photographs, but in reality, their glow is faint to the human eye, peaceful rather than vivid. The Orion Nebula, for example, is one such nursery, a place where young stars are forming softly within a cloud of interstellar dust. When I imagine drifting near it, I picture a wide, velvety cloud with a gentle lavender hue, lit here and there by clusters of newborn stars shining like small, silent lanterns. These newborn stars warm the gas around them, causing it to emit a soft light. But even as they shine, the overall feeling of the nebula remains calm, not explosive, not chaotic. Simply a slow and ongoing process of illumination in a quiet corner of the galaxy. Inside these nurseries, the forming stars, called protostars, grow slowly as gravity pulls more material toward them. They are wrapped in thick cocoons of dust that dim their light, making them appear as warm, fuzzy glows rather than bright points. I imagine these protostars resting inside their dust-filled cradles, slowly spinning, slowly heating, slowly gathering enough mass to ignite nuclear fusion in their cores. When fusion finally begins, it is not like a sudden lightning strike. It is a gentle transition, a quiet spark deep within the protostar that slowly stabilizes into the steady light of a young star. In this way, star nurseries feel like peaceful workshops where the galaxy shapes new suns with a softness that spans millions of years. Some stars formed in these nurseries remain tightly together in clusters for long stretches of time. These open clusters are like families of stars, born from the same cloud, still traveling together through the galaxy. I picture them as groups of young lights drifting across the spiral arms, their brightness fresh, but their arrangement loose and relaxed. They glow with youthful warmth, yet their motions feel unhurried. Over time, some stars drift away from their siblings, moving into the wider disk of the galaxy, while others remain in the cluster until it gently disperses. This slow separation feels natural, as though the galaxy allows each star to wander at its own pace, carrying with it the soft memory of its birthplace. Some nurseries produce stars that shine intensely for a short time, massive, hot stars that burn blue and bright. But even these powerful stars contribute to the calmness of the nursery, because their light gently shapes the surrounding gas. It creates sweeping, glowing regions where the dust forms soft, curved patterns like sculpted clouds in a quiet sky. These shapes may look dramatic in photographs, but when I imagine them in a bedtime tone, I feel their presence as gentle expansions, slow and steady, like a warm sigh moving through the nebula. The gas drifts outward softly, creating room for new pockets of star formation to grow in darker, quieter parts of the nurseries. Dust clouds grow so thick that they block almost all light. These are the coldest, calmest regions of all places, where the material rests in a deep stillness. Inside these cold cores, some of the smallest stars and brown dwarfs form, their births unfolding with a quiet that seems to echo across the entire cloud. These deep, shadowy places feel like the silent rooms of the galaxy, where the most peaceful forms of star formation take shape. I imagine drifting through one of these dark pockets, surrounded by quiet dust and faint starlight, feeling as though time itself moves more slowly here than anywhere else in the galaxy. As each new star grows and the dust around it begins to clear, a young stellar light emerges, shining softly through the surrounding nebula. The dust scatters this light, creating gentle halos and subtle colors. I imagine these halos as soft glows that spread across the cloud like quiet ripples, adding warmth to the otherwise cool darkness. These young stars often still hold onto disks of gas and dust around them, disks that may someday become planets. Even these disks rotate slowly, calmly, like peaceful rings of material circling under the newborn star's warm glow. New stars often form in groups, and when they emerge from their nursery clouds, their combined light gradually illuminates the region around them. They may carve out cavities in the gas, creating open spaces where their light can travel freely. But even these cavities feel gentle in my imaginations, slow openings shaped by soft winds from the young stars, like clearing patches in a foggy meadow. Over time, the glowing region may grow larger, but the process always feels unhurried, unfolding naturally as the young stars continue to shine. When the nurseries eventually disperse, sometimes by the gentle push of stellar winds, other times by the slow gravitational drift of their material, the stars that formed within them drift out into the galaxy. They carry with them the light of their youth, the quiet glow they developed during their time in the nebula. I imagine them exiting the cloud like candles being carried into a large, open room. They join the population of the Milky Way, becoming part of the vast family of stars that fill the disk. Their origins in the nurseries may fade from sight, but each star carries within it the memory of the soft, warm cradle that gave it form. Some of the brightest patches in the night sky are remnants of star nurseries regions where star formation has recently occurred, or is still happening, their glow reaching us from thousands of light years away. When I observe these patches in my imagination, I see them as calm beacons of the galaxy's ongoing life. They are reminders that the Milky Way is not a motionless structure. It breathes, It evolves. It quietly creates new light in the soft, drifting clouds scattered across its arms. The entire process of star formation, from the gathering of gas to the slow ignition of new light, feels deeply calming when viewed across the immense timescales involved. Millions of years pass in quiet preparation before a single star is born. Whole clouds drift gently through the galaxy, holding within them the seeds of future suns. Nothing hurries. Nothing pushes. Everything unfolds naturally, peacefully, as though guided by the galaxy's softest rhythms. And as I imagine these nurseries glowing quietly in the darkness, some warm and bright, others cool and shadowed, I feel a comforting sense of balance. The old stars of the halo, the steady sunlight of the disk, and the newborn stars of the nurseries all coexist in the same gentle structure, each playing their part in the long, patient evolution of the Milky Way. The nurseries are the galaxy's peaceful workshops, shaping the stars that will someday drift through its arms, adding their soft glow to the night. In the stillness of this thought, I feel the calmness of the galaxy settling around me, the quiet glow of star nurseries, the slow birth of new light, and the gentle way the Milky Way continues its life among the dark, peaceful stretches of space. When I let my thoughts drift toward the quiet future of the Milky Way, I picture the entire galaxy gliding through the cosmic darkness with a stillness that does not depend on silence, but on the enormous scale of time itself. Nothing in this journey feels hurried. Nothing arrives suddenly. Everything unfolds across billions of years, so gradually that the galaxy seems almost motionless from any human perspective. As I imagine this movement, I see the Milky Way wrapped in its peaceful glow, turning slowly as it drifts forward, carried by gravity in a gentle path shaped long ago when the universe was young. The stars within it continue their patient orbits. The spiral arms sweep outward in soft curves, and the halo stretches around it like a dim, protective cloud. All of this moves together, drifting across a universe that is far wider, deeper, and quieter than anything we can truly imagine. There is a comforting softness in the way the Milky Way travels. Although it moves at hundreds of kilometers per second, the motion feels smooth because space itself has no wind, no resistance, no sound to interrupt the stillness. The galaxy does not push through space. It simply glides, following the natural pull of gravity from surrounding clusters of galaxies. These clusters, too, drift along slow, ancient pathways shaped by the subtle distribution of matter that fills the universe. I imagine the Milky Way as a glowing island floating gently in an endless, quiet sea, its journey steady and unbroken, its spiral arms turning like soft currents beneath a night sky without end. As the Milky Way moves, it carries with it countless stars of different ages. Some are young and bright, still wrapped in the delicate dust clouds where they formed. Others are old and steady, having orbited the galaxy more times than the human mind can easily count. Many stars travel in the disk, following the calm curves of the spiral arms, while others drift through the halo, moving on longer, slower paths that rise above and dip below the galactic plane. All of them remain together in a cosmic family shaped by gravity's gentle hold. Every orbit is a quiet loop that can take hundreds of millions of years to complete. Yet each star follows its path with steady patience. In this way, the entire galaxy feels like a slow, serene dance, with every light moving gracefully in harmony, far ahead, beyond the long stretches of time we usually think about. The Milky Way continues its drift toward the Andromeda Galaxy, This future meeting is not a collision in the loud, dramatic sense we might picture, but rather a calm merging of two great spirals over the span of billions of years. Even though both galaxies move rapidly through space, the vast distances between stars mean that very few of them will ever come close enough to touch or interfere with one another. Instead, when they meet, their shapes will slowly blend. The spiral arms will stretch, curve, and eventually form a larger, smoother structure. Over another long stretch of time, the combined stars will settle into a new galaxy, often called Milky or the Milky galaxy. This peaceful blending is part of the natural life cycle of galaxies, a quiet reshaping that follows the pull of gravity rather than any sudden force. Thinking about this faraway future brings a calmness to the mind. The universe moves so slowly that even events as grand as galaxies merging unfold gently. Nothing happens abruptly. Nothing interrupts the steady rhythm that has guided the Milky Way for billions of years. When I picture this meeting with Andromeda, I imagine two soft spirals drifting closer, their stars passing quietly by one another, their shapes stretching like wisps of light until they overlap. The process takes so long that even during the moment of closest approach, the night sky on a distant future Earth, if Earth still existed, would brighten gradually, never suddenly, with new clusters of stars appearing like faint lanterns in the sky. The entire event would feel more like a slow unfolding than a dramatic event, a continuation of the same gentle journey the Milky Way has always followed. Beyond this future merging, the Milky Way will continue drifting through space within a much larger structure known as the local group, a small family of galaxies bound together by gravity. The local group itself moves through the cosmic web, a vast network of filaments made from dark matter, gas, and clusters of galaxies. This web is so large and so quiet that its slow motion is nearly impossible to sense. Yet it shapes the path of the Milky Way, guiding it along currents of gravity that extend across hundreds of millions of light years. When I imagine the galaxy's movement through this web, I see it as a tiny, glowing leaf floating gently along an invisible stream, carried by forces that unfold across unimaginable distances. Inside the Milky Way, the calm journey continues on smaller scales as well. Nebulae drift slowly through the spiral arms, their delicate clouds illuminated by nearby stars. These clouds move with the same peaceful pace as everything else, gently stretching and reshaping over millions of years. Some of these nebulae eventually collapse under gravity, forming new stars that shine softly against the darkness. These stars then join the quiet orbit of the galaxy, becoming part of the long journey that has no beginning or end from our perspective. Every star, cloud, and particle of dust moves with the same graceful patience, guided by the gentle pull of gravity that binds the galaxy together. Even the central bulge of the Milky Way, with its dense cluster of older stars and its supermassive black hole, participates in this serene motion. The black hole itself is not a violent creature, but a calm, steady anchor at the center of the galaxy. Though its gravity is strong, it does not pull in everything around it. Instead, most stars orbit peacefully at safe distances, following paths that remain stable for billions of years. The center glows faintly with the combined light of old stars that have lived through many cycles of galactic rotation. This central region adds to the Milky Way's sense of stillness, holding the galaxy together with quiet strength. As I let these images settle in my mind, I find a certain comfort in the idea that the Milky Way's journey has been unfolding for so long and will continue long after our time has passed. The galaxy does not rush toward its future. It glides, turning slowly, drifting gently, following a path shaped by gravity and time. This calm movement reminds me that the universe, despite its immense size and complexity, carries its structures with grace. Nothing is hurried. Nothing is abrupt. Everything flows in soft, steady rhythms that stretch across ages in this quiet thought. I imagine floating far above the galaxy, watching it glow softly against the deep darkness. The spiral arms shimmer faintly, the halo spreads like a gentle mist, and the center glows with warm, steady light. All around it, empty space stretches outward in every direction, peaceful and silent. And in the middle of that silence, the Milky Way continues its calm journey, drifting slowly across cosmic time, holding within it countless stars, planets, and quiet worlds, each carried gently by the vast, soothing flow of the universe.